Okay, so what I'm going to do in explaining forces is to start with the basic force, and then we'll just increase in complexity because that's where people get stuck. And when I say complexity, I mean when we start bringing angles into play. So if I have a 10 kg block, I obviously have force acting downwards, which will be mass times acceleration, right? Fg. And this would be 9.8 times 10. And then I have the normal force acting upwards. Okay, and that's going to be the same. Well, let's say equal to Fg. So this would be a force diagram, and this is our free body diagram representing. So often they ask you to draw a free body diagram, and it will just be like that for this scenario. So that's not too tricky. But now where it does get tricky is when they now suddenly put it on a slope. Do you have your calculator with you? Yeah. Do you have your calculator with you?
Yes, I do.
Okay, cool. All right. When this is on a slope, we still have Fg being the same.
Sorry, it kept disconnecting and reconnecting.
Okay. But that's fine. You can watch the video if you missed anything. So,
Okay. Sorry, Nick. I'm so sorry. It kept the Wi-Fi is so shaky with like all these.
No, it's all good. We just got an inverter, luckily. So yeah, but our Wi-Fi it still goes on the blink every now and again. So what's happening here is that if I have this this thing that this is the thing that I use to write. So I'm going to put this. Seems pretty light. Okay, so I've got this object. So when this is straight, the gravity is pushing down and the normal force is pushing up. Now, as I tilt this, we're going to notice that at some point, there it is, it starts to move. Why? Well, because gravity is acting down the slope. But why didn't it move straight away? Well, because of friction, right? So, because there's still some force acting into the slope, which means I'm going to get friction. So, what's happening here, Fg, is this Fg is being divided into two different forces. The one that's going down the slope, and the one that's going into the slope, parallel. Yeah, so those purple lines are what it's being divided into. Let me make it a different color. I'm going to make it pink. Okay, so you're going down and in. All right, so I'm holding this up again. There we go. What's happening? All the force is going into the mouse pad, or whatever this thing's called. And then if I move it up, now as I move this, less and less force is going here, and more is going down the slope. So as I tilt it, we get more and more down the slope. So, in other words, if I change this angle from 30 degrees to 60, then this force here down is much bigger. And if I make it 90, it's basically free falling. And so there's no force into the slope. It's all going down the slope. So, or into the hill. Okay, so where students get confused is when we start to talk about the sine and cos. So all I'm going to tell you is that one of these is sine and one of them is cos. So purple could be sine or cos, pink could be sine or cos. But my technique, rather than, because you have various diagrams, it gets quite confusing, is to actually put both, then work out which is which. Okay, 10 times 9.8 sine 30. Now we get our calculator. Can you do the cos 30? I know sine 30 is a half, so this one's easy. 49 newtons. Okay, what's 10 times 9.8 times cos 30? You got the answer there?
Oh, sorry, Nick, I was muted. Yes, yes,
Okay, well,
yes. I'm getting 84.87.
84.8 newtons. Okay, now
Yes.
what I want to do is actually move away from learning parrot fashion, like vertical is sine, vertical is cos. I want to get away from that because you can pull an object, you can push it up. There's so many ways you can do things that learning parrot fashion is not as good as understanding. So what I'm going to do is this. If I have this here, okay, without an angle, what do I get? So there's no angle there. So I would have 10 times 9.8 cos 0, because there's no angle, and 10 times 9.8 sine 0. Now the cos 0 and the cos 0 from trigonometry, you put that in your calculator, you'll get the full 98. Sine 0, because our sine graph starts at 0, is 0. Okay. So how does that make sense? Well, the pink is the one that's going into the slope. So that must be cos, because there's no force. If I have no angle, there's no force going down the slope. So the purple must be the one going down the slope. That's the first way we think of it. The second one is to go, where are these forces going to be equal? They're going to be equal when this angle is 45, because that's half of 90. Because we know sine 45 and cos 45 are the same. So if this is smaller than 45, the bigger force is going to be into the slope, and the smaller force, because it's less of an angle, is going to be down the slope. Right? So the bigger force, because it's 30, is smaller than 45. The bigger force is still going into the ground. So the bigger force, the pink one, because this is 30 degrees, that is going to be my force into the slope, and going down the slope is my 49. Okay, going down the slope. If I increased my angle to 60, we would have the opposite happening. Now most of the force is going down the slope. So from this, you can now work out a bunch of different things. One of them is the normal force. I now know the normal force is going to be now the same as the pink force. So Fn will be 84.8. The other thing I can do is I can figure out this acceleration of this object. Because force equals mass times acceleration. What the acceleration, I'm assuming this is a frictionless surface, by the way. Otherwise, we would have to bring that into play. But acceleration of object is equal to the force over the mass. And we know the force is 49. And the mass is 10. And so the acceleration of this is going to be 4.9 meters per second squared. So just getting given the 10 kilograms and the angle, I'm able to work out the force of the normal force. I'm able to work out the force down the slope. I'm able to work out the acceleration of this. And then if I was to add friction, then I could then now do a separate calculation, which we can maybe do because there's only a minute left. So I think we can end that there. It's sort of an introduction to forces, and then how the angle can create complexity. But just think logically about where's the bigger force. When it gets separated into two separate ones, which is the bigger of the two? And we can just think logically about it rather than having to learn.